Sir Isaac Newton was a mathematician and a physicist, one of the foremost scientific intellects of all time. He was born at Woolsthorpe near Grantham in Lincolnshire. As a child, he wasn't always smart. Newton failed out of school at the age of 14. After he failed out of school, Newton began observing falling apples from a tree.
During these observations is when he discovered his three laws of motion. Another influential person in Newton's life was Galileo Galilei. After this, Isaac Newton went on to make many other things such as calculus and the prism. He later died on March 20th, 1727. His legacy will go down in history forever.
We're going to be demonstrating Newton's first law. Newton's first law states that every object continues in a state of rest or of a uniform speed in a straight line unless acted on by a non-zero net force.
Right. In this demonstration, we'll be showing that as a car moves, your body moves at the same speed as the car. But when the car stops, your body still continues to move at the same speed. That's why you lurch forward. Your seatbelt is the outside force that stops you from going completely through the dashboard.
As you can see, our bodies stay in the same speed as the car unless we hit the brakes and stop, and then our bodies go forward.
As you can see, again, as you move forward and in a car and stupid idiot pedestrians decide to come out in the street, you slam on brakes and you go forward.
This is the second demonstration of Newton's first law, the law of inertia.
Okay, it says that an object at rest will stay at rest until an outside force moves upon it. So the force has to be really hard. So me just pulling this out is not going to do anything. But it'll stay at rest until force acts on it to make it do otherwise. So if I do this, they all fall. This will be the demonstration of Newton's second law. Newton's second law states that the acceleration produced by a net force on an object is directly proportional to the magnitude of the net force, is in the same direction as the net force, and is inversely proportional to the mass of the object. So, me pushing this, it'd be easy pushing this, but with a person in it, it'd be really hard.
Now, as you can see, we have a person in the bucket. And as a demonstration of Newton's second law, when you have more weight in the bucket, then it's harder to push or pull. So, as you can see, it's harder to push because there's more weight in the bucket. Also, it is harder, oh my god, it's harder since there's more weight. And so, that is Newton's second.
This is a second example of Newton's second law of motion. If I push these two buckets with the same amount of force, the one with the bigger mass won't go as far as the one with the smaller mass. This is an empty bucket, so it barely has any mass. But this bucket has a lot of stuff in it, so it's kind of heavy. So if I push this one, it goes pretty far. But if I push this one, it won't go as far as the one with the smaller mass because it needs more force.
Newton's third law states that whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first object.
I'm going to be demonstrating Newton's third law. The most common example of Newton's third law is walking. When you walk, your feet push down on the floor, and the floor pushes back on you. So you move forward instead of sinking through the floor.
Another example of Newton's third law is a dog walking. When a dog walks, the legs go backwards. The legs go backwards, but the dog goes forwards. That's another example of Newton's third law.